Okay, let's talk about converting moles into liters and liters into moles. Okay, like everything else, we have a conversion factor. Okay, and that conversion factor is 1 mole is equal to 22.4 liters of gas STP. Okay, and so you may be asking, what is STP? STP is simply standard temperature and pressure. Okay, we will not be dealing with anything that is not standard temperature and pressure. So you don't have to worry about what that does or what that changes. Just know that when you see that on a problem, it doesn't really matter to you. It just means standard temperature and pressure, okay? Now, the second thing you have to know is that this is of any gas, okay? It doesn't matter what the gas is, okay? The type of gas does not matter. It could be oxygen, hydrogen, CO2, methane, whatever. Any type of gas is going to occupy 22.4 liters per mole. Okay, so let's do a couple of examples real quick. How many liters does 1.7 moles CO2 occupy? Okay, so again, we're going to take what we have, what we're given, 1.7 moles. We're going to immediately put the moles down in the next chamber. So 1 mole, again, 1 is always the number with mole in the conversion factors. All right, and then we're going to convert that into liters, which is 22.4 liters. So again, multiply across the top, 1.7 times 22.4, divide by the bottom, which is just 1. Okay, and you end up with 38.08 liters of CO2. Okay, because our moles divide out and we're left with liters, which is what we want. Okay, so 38.08 liters is your answer. Let's go the other way. Okay, how many moles are in 39.4 liters of gas? Okay, and if you're asking yourself, well, what type of gas is it? Well, it doesn't matter, because again, all gases occupy the same amount of volume. Okay, so we're going to take what we're given, which is 39.4 liters. We are immediately going to put the liters in the bottom section of the next chamber. All right, so liters, the number that is associated with liters is 22.4, and that is going to equal 1 mole. Liters divide out, you're left with moles. That's what we're looking for. So 39.4 divided by 22.4. Okay, and that's just going to give us 1.76 moles. Okay, nothing too difficult. It's the exact same process. We're just using a different conversion factor. Okay, remember in the beginning we talked about 3 different conversion factors. Okay, so what I'm going to show you now is the mole map. Okay, and the mole map, which will be given to you, is just basically a roadmap when you're using multiple conversions. Okay, when I give you liters or grams or moles or particles, and I ask you to convert those into any one of those, you can use your mole map to help you out. Okay, so we have the mole in the middle. All right, and on one side we have mass. All right, on one side we have particles. And then on the third side we have volume. Okay, because these are the 3 things that we can convert using the mole. The key is to be able to understand what you need in order to convert mass to moles, or particles to moles, or moles to volume. Okay, so let's say that we are going from moles to mass. Okay, we have this pathway right here. We're going to use the periodic table. Okay, we're going to find the molar mass of something and then set it to 1 mole. Okay, so we're going to use the molar mass using the periodic table. In particles, remember, those can be atoms, those can be formula units, ions, those can be molecules. All right, any of those are going to be acceptable particles. Okay, and the number that we use to go from the mole to the particle is your 6.02 times 10 to the 23rd equals 1 mole. Okay, let's say we're going down from the mole down to volume. Okay, you're going down this section right here. Your conversion factor is 22.4 liters per 1 mole. All right, so if let's say that I've given you mass, okay, and you need to go to the mole, well, this is the path you're taking, so what are you passing up? You're passing up the periodic table and you're passing up the molar mass, so that's what you're going to use. Okay, let's say I've given you the mole, and you need to go to, let's say, molecules. Okay, again, this is where you're headed, so what you pass is what you're going to use. That's your conversion factor. Okay, and later on when we get into multi-step problems, you're going to be able to use this, okay, to calculate how many grams are in a certain amount of volume, how many particles are in a certain number of grams. Okay, so that's just going to be a 2-step problem that you have to deal with. Okay, so let's look at a quick scenario where you might have a 2-step problem. Let's say that I give you mass and I ask you for volume. Okay, well, you can't go directly from mass to volume. There's no conversion factor for it. So you have to go from mass to the mole, use your molar mass as 1 conversion factor, then go from the mole to volume using your 2nd conversion factor. So it's a multi-step problem. Okay, but that's going to be taken care of in a later video. So this is just a brief overview of the molar map, the mole map, and converting moles into liters and liters into moles.